The focus of the examples that I'm using now for finding quadratic equations given its roots or zeros are the special quadratic expressions that I'll generate. Let's study the vocabulary term multiplicity first. Multiplicity is the number of times a specific number is a root or zero for the polynomial. So, in my first example here, I have 10, which would be x equals 10, but it says I have a multiplicity of 2, which means I'll have to use x equals 10 twice, each one generating x minus 10 equal to 0. So if I have a factor, x minus 10, and I'm using it twice, I could rewrite it as x minus 10, the quantity squared, and equals 0. This is going to generate what is called a perfect square trinomial. How do we generate that perfect square trinomial? Don't be in a rush to just square each piece because that would be done incorrectly. You need to FOIL. So, write out x minus 10 times x minus 10 twice and go through the process of FOILing, where the first term is x squared, the outside term is minus 10x, the inside term is minus 10x, the last term is plus 100, it equals 0. Remember, the two linear terms are going to be the same. So I could take either one of those linear terms and double it and come up with x squared minus 20x plus 100 equals 0. And what you have here is a perfect square trinomial because its factors is a quantity squared. Let's look at my second example where I have x equals both positive 4 and x equals negative 4. If I were to generate the equations that will generate the factors, I will come up with x minus 4 and x plus 4 multiplied together, of course, equaling 0. You might recall when you see factors like that, these are known as conjugate factors. And what will happen is when I FOIL those terms out, I should expect the middle terms to drop out. Well, let's see. The first term is x squared. The outside term is positive 4x. The inside term is negative 4x. Let's make sure we distinguish that. And then the last term is negative 16 equal to 0. And again, if I focus on the two linear terms that are right here, you will see that positive 4x and negative 4x do cancel each other out, leading to x squared minus 16 equals to 0. If we look at the expression x squared minus 16, this is known as the difference of two squares. Why is that? Let's look at the x squared. X squared is really x, well, being squared. All right, not too hard there. But when I subtract, hence the word difference, I can think of 16 as 4 being squared. A difference of two squares is when you go a squared minus b squared, or in this case, think of a as x and b as 4. A squared minus b squared will always equal a pair of conjugates, a minus b and a plus b, the same two conjugates that we get right here. Okay. We can then take a minus b and a plus b, FOIL them out, and realize we will always get a squared minus b squared.